ROS2 in C++. Most of the people might think that why do we need C++? It's really complicated when they are starting, because the very basic thing of C++ in ROS2 is still implemented with very good practices. So it makes things difficult to understand when they are not good with C++. So I'm here to make it really easy how to use C++ in ROS2. And the important thing is C++ is the go-to choice when you are working with a real robot, even with ROS2 system, because it's good, closer to the hardware. Coming to the main thing, we are going to be understanding the C++ nodes of ROS2 in 3 steps. The first is going to be how to change common features of a node. The second one is callback function, in which we'll look into logging, shade pointers, and some details. The third one is publishing different messages and looking at how we can include different header files of messages into our node. And when we are working with this, we will be understanding more about how C++ software development practices are utilized, what is CMake, how it affects the whole writing of the code and execution of nodes. So let's start with the first one. So Visual Studio Code is going to be utilized for code writing and managing our workspace. The first thing is going to be looking at how to create a node. I already have a workspace and I'm going to add it from the ROS2 workspace, source, add. Although there is no package inside of my workspace, so I have to create a package. To create a package, the command is simple: ROS2 package create. You are going to mention the build type. That was not the case in ROS1. In our case, as we are working with Emerald CMake, we want C++ package, only pure C++. The next thing is going to be the name of the package. We are going to say ROS2 wiki or just nodes. Press enter. I think this is Emerald CMake. Now it has been created, and accidentally I have created it in downloads. This is a mistake that you don't need to do. You have to get into your workspace. This is important, otherwise you need to source it. So let me run that again, and now I have the package here named as nodes. The very first thing I'm going to do is to go back and perform colcon build, just to save the build files so that I can source this workspace. I already have created a link for the source, and what I mean by that, if I open my workspace, you can see there's an install folder, there is a setup.bash file here which is already sourced, so I don't need to add that. Now we have the package, and now we have to add nodes. I have to go here, which is documentation of Foxy. We are not working with Foxy, so I am going to Humble, which is the latest one, as I have already installed Humble. So this is the documentation. There is, I think, not much difference in the node structure. It has already explained you can create a package like this. You can directly download a file, that is a publisher, but we are going to create one and understand how to add it properly in one package. I'm going in the source directory. I'm going to say a publisher.cpp, press enter, and I obviously am going to be adding a subscriber as well later on. Pasting the code, saving it. I know this code doesn't make any sense. It provides explanation that we will look into later, but first we are following the first part of the video, which is changing just the simple features and make it work. So the next step is you have to add the dependencies into your package so that it understands that you have this node working. You can see it says your node is actually depending upon RCL CPP and standard message string. So in package XML, it says that in build tool image CMake, you are going to bring these to tell the package that when you compile, keep these two in mind as well. CMake list, this is the important part because most of the people make mistake here and their nodes are not working. So let me put this side by side now. CMake list. So why do we need CMake list? For your basic understanding, CMake is a system that automates your compiling and making an executable C++ file. So you can say it's a system, although apparently it's just a file. If we take a look here, you can see this is just a simple file, cmakelists.txt. It provides the compiler version that we are using and other properties that we are not going into. Build testing that we will not be using. So I'm going to create some space here and I am going to fill it with the help of this wiki. It says that you are going to first write in the packages that you are using. It's not just these packages. Later on we'll see that there are other things we can add as well when we are including in our C++ node. The next thing is adding our executable path and target dependencies. What I mean by that, this is going to be the name of my C++ node, that is publisher.cpp, that is placed inside my source directory. The spellings should be very accurate, publisher. And when I create an executable out of it, what should be the name of the executable? I am going to say it is pub node. Okay, and that is going to be, again, when it is going to be producing an executable, it is going to be requiring the linking to the libraries it is using. As we can see, the publisher is using these libraries. These are built-in libraries. We don't need to link with them, but RCL, CPP and string, which is ROS based, so we are going to mention these two here. If we have other libraries, we are going to write them here as well. In our scenario, that's it. The first thing we are going to do is now compile it. For now, before moving on, if I say ROS2 run, my package name is node, and if I press double tab, there are no nodes, so I have to build it. The build process is complete. If I say ROS2 run my package name and double press tab, it is not going to show me the nodes. The reason is it's not just about producing an executable and linking the executable with the required libraries. There is one last step that is very important, and that is install of C make list, which provides targets, and you install it so ROS system can access the executable because it is placed in the lib directory with the project name, so it can access it. Now when we build it, we are going to have the node that we were working on, ROS2 nodes, and I think I was making the mistake of not putting S, but either ways the node would not have appeared. Pressing double tab, it says now prefix, and we have pub node as well. Our node is there. Let's run it, and it is publishing. So the node is working. We'll look into the code as well later on, but the code is working. If I go down here in the wiki, there is another example as well, which is of subscriber. Let me copy that, and interestingly, you have to follow the same step again that we did for publisher, and this time we have created the subscriber and there is code as well. We don't need to copy these find packages because the subscriber is using the same that we have included once, and we don't need to again and again do that. The next thing that we need to do is to add the executable, and this time it is going to be subnode. This is going to be subscriber, and then we copy and paste it to link the libraries to this executable, and we also add it here in this list, and this brings it into the ROS ecosystem, and it knows where this file is. The important thing is we just copy pasted the codes, right, and they don't make any sense. We have not even looked at the code, so we just have to first understand how to make it available for ROS, because the codes are going to be working as they are from the wiki. Then we are going to start understanding how the code works. Okay, so let's first run the code, make them publish and subscribe, then we will make some changes in the main features of the node. So I would be needing two different terminals, ROS2 run nodes, and there is one is pub node, and ROS2 run nodes and subnode. Subnode is not there because it is not yet built. Now let's run ROS2 run nodes and subnode. You can see it has started from this specific point where it is publishing. Both of our nodes are working. Let's take a look into the main features that we can make changes and understand more about these nodes. Stopping it, going inside of publisher and subscriber. Let me put them side by side so they make more sense. If we directly look at the code, if you are not good with C++ programming, let me just give you a brief understanding. This is the main function that executes first whenever we call a C++ file. Then this is a class that is being called inside of this main function, so this class is also utilized. These are the libraries that we include, and a namespace is utilized, which I will explain later. The thing is, it is working, it is publishing and subscribing. If we just make some changes in the main aspects, which are name of the topic, I am going to say pub sub topic, or I should say Lukman topic. And this is the name of the topic on which communication was happening. The next thing I can make change of is the string data type, but I will leave that for now because it is a little bit complex. And I am not going to be publishing hello world, the message that we are publishing. I am going to say nodes for CPP says this, and I'm not going to say about publishing. I'm going to say just print out this message. So a message has been tempered, topic name has been tempered. Now if I run these nodes, they are not going to show us the change, because in C++ and specifically ROS2 this time we have to perform call can build again, and it updates the executable that it has already created, so the changes are then saved. Now if I run the node, it is going to say nodes for CPP says 01 this, but the problem is this sub node is not going to subscribe. This is the basic concept of ROS. For this node to subscribe, the subscriber, you need to provide the exact same topic. And that's it. We just need to perform call can build because we have made some changes and it needs to replace the previous executable, and then we just run this new executable and it says I heard nodes from this. Both our nodes are communicating. Coming to the second part, and that is callbacks and logging. Callbacks are something that when we receive something, we go to a function that what to do with this data. That's callback. And logging is taking a look into what we have received, sort of debugging as well, to look at the data, how we can utilize it and manipulate it. Let's dive into it. Here we have our publisher and a subscriber. What I am going to do is I'm going to make some changes here. And the first change is going to be adding another topic for publishing and subscriber inside of these two nodes. Okay, and if we take a look into the code, there are 2 to 3 things that we have to keep in mind. The first one are the shared pointers that are utilized, then the callback function, and this member function that we utilize for creating publishers or subscriber. I am going to utilize another message type, that is standard message integer 16. And how do I know that? You can just go into your terminal, and inside of terminal you can list out your interested message type by opt ROS. I'm doing it again so you can have better grip on it. Standard messages, first humble include directory standard messages, and inside of standard messages, then again standard messages, then standard messages. I'm pressing tab, it automatically completes. Now I am going to press IN and double tab, so it is going to tell me about all integer available types. I am interested in int 16 HPP, so I will include that in my code. There is int 8 as well. So int 16 HPP, yes, it has been included. I am also going to add it into the subscriber side because it requires the data type on which it is performing all of the receiving and processing. Inside of publisher, let me add another publisher, and I am going to name it to be publisher. Let's call it publisher 1 and publisher 2, so we can easily distinguish between them. Okay, the callback functions and the name of the topics and every object is now replicated. Just this shade pointer is not replicated. So I'll just replicate it as well because this publisher is utilized at this point, and I have to make the changes for the timer or shade pointer as well. But the question is, what are shade pointers? Shade pointers are smart pointers. They are utilized for dynamic memory allocation for pointers. For CPP guys, obviously this will make sense, but you have to understand it in a way. A shade pointer holds a pointer to an object. In our case, object to the class, the node class, and it's the publisher that we are using. So shade pointer points to that object, and when we get out of the scope of that object, it automatically frees up our memory. It is really amazing because of the efficiency that it provides, frees up memory, although there are some cons as well. But in basic nodes example in Wiki, shade pointers are utilized, so we have to just have a basic understanding of it. So at this specific point, this shade pointer is holding a pointer of this publisher 1, and that pointer has this specific data type, although it's long, but that is the case. So when we get out of this whole minimum publisher class, it goes out of scope, and this shade pointer is automatically deleted from the memory. So where were we? So that was all C++ programming practice that we have to keep in mind. The next thing that we have to do, as it is integer 16, I am going to make the change integer 16, as the data is going to be different from publisher 1. It is not going to be logging. So the interesting thing about callbacks are there is a logger. In callback functions, we have these two things, RCL, CPP, info. There are other options as well, some warn, error, things like that. So you can print out the information on the terminal that is a logger. So this function is called logger, and in our scenario this one is a string because the first publisher is a string, the second one is an integer, so we don't have to convert it to a null terminated string with this function. We just need to provide the data, and we are going to say, as it is in integers, just say this, and I'm going to say int publisher and string publisher. They are going to represent the messages. Before moving on, whenever we are copy pasting things, there are a lot of mistakes, especially you can see this time 1 is a problem, and this is not a string message string something, and it is integer 16, and it's not a small one, it's a big one. When we write the data types with the message, it's in this scenario it's bigger because the definition of the class, but when we are including, we include the name that is there, the header file's name. So the last thing is the message type. As you can see, auto is used. Auto means whatever this data type provides, whatever the object it creates, you are going to auto assign the data type, so we don't have to write this big thing again and again. In our scenario, we have to change that here as well. Message data is going to be a number. Let me just say count plus plus. You're just going to add that number to the data, and you are going to log it and then publish that message here. In the string scenario, the data is converted into a string, as you can see, and then it is logged as a string. Everything seems to be fine. Let's compile it, and then we'll see if there are any errors, we can fix it. And here we have a problem that I left intentionally, because when you are doing the copy pasting, you have to be really careful. The name of the publishers are not changed, and that's why this was being a problem. So our nodes have been successfully built. ROS2 run, what is the name of the package? Nodes. And we have pub node. We'll keep it on the left side. As you can see, this one is yellow as it is a warning. Warnings are yellow. And let's try another one. Leave this, and that was error or fatal, something like that. Let's see if that was the case. We are going to be needing another one. So we can ROS2 run nodes, and the node that we are interested in is sub node. Let's run it. Although the sub is not going to be subscribing, as the one single subscriber is there. Let me just run this node, and this time you can see this one is appearing red because I have said that log it as an error, and it is logging it as an error, and it is red in color. Warn is in orange in color, but the thing that is happening, this is integer publishing, this is string publishing. Similarly, if we open up our subscriber, we have to add multiple things and make it subscribe to the data. So I'll make it quick because you already understand the main aspects. So in the case of subscribers, we have another thing that are placeholders. I'll talk that in the next part, what is a placeholder and how it is utilized in this bind function. It is really amazing that you bind something with it and it can be used. So I'm trying out this RCLCPP fatal function because I think there was a fatal function as well. So till now everything seems to be fine. What I think is we don't need the second placeholder. We can work with the first one as well, as the wiki suggests. So let's build it. And where is our publisher? This is our publisher, and it is going far ahead than the subscriber. Let me resize it. It's taking some time. ROS2 run nodes, and subscriber node. So you can see one is a subscriber of string and the other one is the fatal one and that is integer subscriber. It is interesting that you can play with this printing as well and utilize it for the purpose they are built for. It is interesting that you can write this error, fatal, warn, info, and I think there is two more options as well. You can find it out on the wiki. Interestingly, we have spent a lot of time with these nodes and playing with the code of it. I think that most of the people would not be able to understand or comprehend the code because of the functions that are used, and I've not explained anything. And I want you to stay like this for some time and write the code in C++ in the callback function and utilize it for your purposes. I'm going to give you just one more example how you can utilize for messages of different type, like laser message. So you can visualize the data, you can add the fields and understand how ROS messages can be utilized in your own publishers. The first thing I'm going to do is create a copy of it, and I'm going to say laser publisher. This is going to contain almost the same things of the previous one, just going to add some new message types. We only need one publisher, and the timer callback, or I should say the callback function, is going to be one single function. We don't need the count, and we are going to remove this count as well. Everything is going to be to some extent similar. Just let me give some proper names to it. This time I think I have to give a proper name to the class. It is going to be laser publisher class, and this is the point where it is being called and a shared pointer is created and everything seems to be fine. We are now going to understand how laser message is being published. If we take a look here, we have to first get into the opt ROS humble include sensor message directory, and inside of that there are messages, and I want to look at the laser messages. Double tap and it is going to tell me about laserscan.hpp. This is the message type I want to utilize. And what is the another thing that I have to keep in mind? If I just search about it, ROS2 interface show and sensor message laser scanner, it is going to provide me all of the details I have to fill if I want to in the message. So what we want to include, it's sensor message, then message, and this HPP file. If I make a mistake of this, it is not going to work. Okay, sensor message is going to be small, it's going to be sensor messages. If we look at this thing, sensor messages, message laser scanner, although it is bigger here, it is upper characters. Coming to the point of data type, here we have to mention the way it is written specifically here, laser scan, and it is not a standard message, it is a sensor message. You are going to be calling it as a scan, and that's it with the public constructor. Let's move to the callback function. In the callback function, we have to create an object, and I am going to be calling it with a proper name, that is scan message, so we can understand what is happening. At this specific point, it is not going to be a count plus plus. It is going to contain all of these values. Let me fill it and then we'll discuss. Now if I bring it side by side, it is going to make more sense. And if I put it always on the top, everything we do with the message and the data of a message, we do it in the callback function. That's basics of ROS. So the first thing is header. I'm going to copy it and I'm going to say scan message dot header, and inside of that we have a stamp. Stamp is the timestamp, and we do it like this. That's how stamp is done. It basically gives you the current time when it is going through this specific line. Coming to the next part, and that is frame ID. Frame ID is what we want it to have, the transform, what we want it to have as a name of the frame. It is utilized by transforms of ROS2, so it is going to be laser frame. Makes more sense. Let me fill all of the values and then we will discuss about that. So here, if we can take a look, all of the things are written, only the angle time increment is not written, and intensities and ranges are not written, although they are really important. We can publish it, but let me create a range array so we can fill in some values and we can then visualize it in ROS. There are other things as well that we have to take a look, but I will just write down the code to add the ranges. This range is going to be defined in this callback. For now, although it's not an efficient way, standard message array of data type float with, let's say, 100 values, and we call it to be range. Then we fill these values with the value of 10. So all of the 100 values inside of this range array are filled with 10 values, and then we set it. Everything seems to be fine. Let me just get rid of this. We don't want it. And we are going to perform the call can build and see if it is going to work or not. It compiled, but the problem is when you are going to say ROS2 run nodes and double tab, it is not going to show you laser publisher, and the reason for that is that we have not added it into our CMake list. This is an important step that you have to do. If we take a look here, first we need to add it to be an executable. In our scenario, the name of the node is laser publisher, laserpublisher.cpp, and we are going to say laserpub to be the name of the executable. This is an important step because if you skip it, it is not going to work. Then we add it into the target. This is what we did for publisher and subscriber. But in this scenario, in this specific scenario, you have to keep in mind that we were using sensor messages, and sensor messages was not included here. If I compiled here, for example, if to make more sense, it is going to say sensor messages. I don't find it. So this error is really interesting. Finding the sensor message, and it is included inside of the sensor messages in our node, but it is not linked with our executable. And if we perform call can build, there will be one more error. I'll show you, but it is not going to be regarding this CMake list. This is what you have to do. Coming to our node, if we take a look here, now the error is not related to the include file of sensor messages. It is related to the range that we have used. It is saying that sensor message laser scan something 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 is a standard vector float, and you have utilized standard array float. I just wanted to show you this part because it is really important for you to understand. Although on the terminal, if I say show me this interface, it just says float 32, and although it is standard message float 32, we have to dig deep to understand that this float 32 is a vector. So I have to just get rid of all of these and just say create a vector. All the vectors are more easy to define. Create a float vector, and this is going to be its size, and this is going to be the all values it is going to have. At this specific point, if we perform call can build, it is going to be building the whole node. Now if I perform ROS2 run nodes, and the name of the node is laser publisher, let me run it. If I open up a terminal, ROS2 topic list, it is going to appear as a scan topic, ROS2 topic echo and scan. If I press enter, you can see I get 100 values of ranges as 10 and other things that I have added as well in each single message. So at this specific point, I am pretty sure that you are now good with nodes in C++. You understand how to control a node, although you might not be able to understand the bind function and how the shared pointers are actually going behind the scenes and doing the dynamic memory allocation. It's fine. You should be able to use the node, add functionality into the callback function and utilize it for your work. That's what you have to do. All the base code, all the explanation can be obtained from the Google and the chat GPT as well. So that's it for the basic understanding of ROS2 CPP nodes. And interestingly, I'm starting another series for path planning for ROS in C++. So this is going to be really useful for you, and we'll fill the whole laser scan message and occupancy message as well to visualize it in ROS and stuff. So see you there.